The reverse engineering of this stuff is obviously impossible. It will require hundreds of hours of work. But we can test with a continuity tester if we can find the stator of synchro transformer on this connector. Normally we should have two outputs. Okay, so here we have a resistance of 5 ohms. Okay, we have another one. So we have three identical resistances. So this is interesting, which seem to be isolated from the rest of the circuit. Okay, so this is probably the coils of a stator. You have another one here, 6 ohms also, isolated. So we have one stator here, it seems, another one here. So we have at least two outputs. So this is interesting. There is also the reference voltage of the synchros. We have another one here, 4 ohms. Now this is a short circuit. Okay. And look at this, guys. I have connected the function generator on these two lines. I have connected also an oscilloscope between these two terminals. And we can see that we have something which depends on the rotation of this gimbal. Oh, and also on the inner one. Also, this will be complicated. The only solution I have is that the input of the generator is on the stator of one resolver and the oscilloscope on the stator of the second resolver, and the two rotors are connected together and to the reference voltage. And in this case, the voltage which is measured depends on the rotation of these two gimbals. I have to find the common rotor signal, which is the reference signal of the synchro transmitters. Okay, so it seems I have found the reference signal, which is on these terminals here. So you can see that now the signal depends only on the rotation of the inner gimbal here, but it is not dependent on the rotation of this one. Okay, so this should be the reference signal. So I will invert these things. I will apply the reference signal on these lines here. And I will connect the oscilloscope here. Okay. And now I should have the signal on the other direction on these two terminals, on these three terminals, but I can measure only on two, and this is sensitive to this one. Fantastic. Okay, and it is independent on the other one. Okay, so we have found actually the two synchros. The reference signal is here. So this one is for the outer gimbal. So I don't know the direction of this thing. It is something like this. Forward on the right. So this one is for the pitch, and the second one for the roll. Okay, so we have the pitch output synchro here, and the roll synchro here, and the reference signal on this line. So I don't know the voltage which should be applied on these lines. Normally this should be 26 volts. So you can see that even without any documentation, it is possible to do something with this instrument. So I don't know the purpose of all other terminals. And I don't know also the purpose of this connector, of course, but it doesn't matter. It can be interesting to understand how this thing works, but of course the reverse engineering, as I said, is obviously impossible. So maybe if I find the documentation one day, I will buy it in order to understand and to make more tests. But for the moment, I will limit my test to connect this thing to an indicator. It is what I wanted to do anyway. Actually, the reference of the synchros is the power supply itself. So I have just connected the output of the synchros of the gyroscope to the input of this indicator. I am going to turn on the power supply in a few seconds. As you can see, the role is inverted, but it doesn't matter. And this was the teardown and the test of this vertical gyroscope associated to this roll and slip indicator. Thanks for watching and see you next time for another instrument. Bye bye.